We want to sketch the graph of this function, and we are using derivatives and asymptotes to discuss. Okay, this is one topic in calculus, right? Now, first, let's find the derivatives. The first derivatives. I suppose you know how to find derivatives, right? So the first derivative of this function with respect to x, and using quotient rule and so on, and then you simplify, you get this result. Minus 4x plus 2 to the x cube. I just save time, no? And this is the derivative, first derivative. And then first derivative equals 0. It means x is equal to minus 2. Okay? We find a critical point at which that the shape of the curve is important. And also we use the second derivative. Second derivative is equal to 8x plus 3x fourth power. Okay, you find the derivative of this with respect to x, then you simplify, you get this. Second derivative equals 0. It means that x equal to minus 3. So these 2 points are important for us to discuss. Okay, and beside that, we need to discuss the asymptote. When x approaches to positive infinitive, when x is very big, infinitive, this is approaching to 0. But positive number, this is positive number. A very small positive, minus 2, is equal to minus 2 and from above, which means a little more than minus 2, because this is positive. Minus 2 is greater than minus 2, right? A little, a very little. And when x goes to minus infinitive, when this one is minus infinitive, this is positive, this is negative. The overall is a very small number, but negative. So this is minus 2 and from below. Okay. Then also that the limit x approaches to 0 from positive side. When x is a very small positive number, and we know that when x is very small, this one is approaching to 0. But positive. No. This is very small. This is very small. Therefore, this reciprocal number is very big. It's infinitive. It's positive infinitive, right? So y is equal to positive infinitive. Now, when x approaches to 0 from left-hand side, when x is a very small negative number, this is also positive. This is also positive. Therefore, overall is a very small positive number. This is, sorry, let me see it again. This is very small. This overall number is a very big. But it's still positive because 1 plus a small negative number, a small positive number, is still positive, but very small on numerator. And overall is very big. So this one is going to positive infinity. So these are quite useful information for us to sketch the curve. Well, to sketch a curve means to collect the information. From the information, we can sketch the curve, right? Now, then I try to organize these pieces of information in a table. This is X. We have 3 points to discuss. One is -3 and minus, well, I'm missing a number. -3, -2, right? Yeah, -2. So, -2 and a 0. Okay, these are 3 points. Divide the whole interval into 4 subintervals, because this function is defined from positive infinitive to negative infinitive x, right? Therefore, the whole interval is from minus infinitive to positive infinitive, just divided by these 3 points. These 3 points are important. This one, second derivative is 0. This point, first derivative is 0. This point, the function is not defined. The function is not defined at that point. So this is one subinterval. This is another. And this is another subinterval. This is this. Okay, good. Then this is a first derivative, this is second derivative, this is y. Now we need the shape of curves of the functions, right? So we can sketch. But the shape of curves is derived from the derivative signs, a positive or negative signs. So we choose a point, say we choose -4. Okay, you can choose minus million. Put this one into the derivative function, you get a negative. Well, put a -3 here, you get a negative. Here, I choose a negative 2.5. You put this one into the derivative, it is negative. At a 0, at a -2, the first derivative is 0. Here we choose a -1. You put -1 here, and you get a positive. Put a 0 here, it's not defined. Here, I'm choosing, say, 1, or you can choose a million, any number. You put it here, it's a negative. I can choose 1, right? If I choose 1, it's negative, positive. So overall, it's a negative. And similarly, that we test the signs for second derivative. Here, I'm choosing -4, or I choose a negative in million. Then, I put it here, it's a negative. -3, second derivative is 0. Here, I'm choosing -2.5. Put it here, the sign is positive. -2, put it here, is positive. Here I choose -1 to test, it's a positive. Here I choose 1 to test, or choose a million, put it here, is a positive. At a 0 is not defined. Okay. Very good. Now, this. When second derivative is positive, the curve looks like this. when second derivative is negative, the curve of the shape look like this. The shape of curve look like this. This part, which curve is decreasing. First derivative is negative. Curve is increasing. First derivative positive. First derivative is 0. Second derivative positive, the minimum. And first derivative is positive, its function is increasing. First derivative is negative, function is decreasing. Overall, the second derivative is negative. This is the shape. And the first derivative is 0 is the maximum. It's a nice picture to summarize. Nice picture summarizes that the shape of curves with respect the signs of the derivatives, positive or negative, right? And this is a bowl, holds the water, it's positive. This umbrella is negative, does not hold water. It's very easy to memorize. Okay, now we can negative. I put them together this way, yeah. Well, it's hard. Okay, this is better. Now, negative, this shape. You see? This is shape. Positive, negative, this is a shape. Positive, this is a shape. Function is not defined at a 0. Positive, negative, this is the shape. You see, it's a very nice way to get the shapes of the curve, right? Then you put -3 into the function, you get y value. Y is a negative 26 over 9. Well, simply you put a value into the y, right into the function, and you put a 2 here. You put a 2 here. This is a -1. Negative 2 here is -1, right? It's a 4. 4 minus is a -3. Yeah. Okay. Almost ready. Then asymptote. Now look this. When x is infinity, y is -2 from above. So it looks like this. No, sorry. I look at this one, right? I took the wrong piece. This one. When x is infinity, minus infinity, y is -2 from below. So it looks like this. Right? From below. This is very far away, 100 miles away from here. The function is approaching to negative from below. This, when x is a positive infinitive, when x positive, not this, I took a wrong this from here. Okay, when x is positive infinitive, y is approaching to 2 from above. So it looks like this. Right? 100 miles from here, far away. And when x is approaching to 1 from right hand side, y is approaching to positive, so somewhere here, right? Positive. When x approaches to this, is a very large positive number. When x is from approaching to negative 0 from left hand side, y is also positive, very large positive, somewhere here. So these are pieces of information, give you the clue of how to sketch the curve. And then we plot the point, right? -3 is according to this one for y. So -3, y is 2 point something, somewhere here. This is the point. When x equal to -1, y equal to -2. So when x is -1, y is -2. This is the point. This is the point. x1 -1, y equal to -2. And when x is equal to -2, y equals to -3. So somewhere here, right? Okay, point. When x equal to 1, this is 8. 8 minus 2 is 6. So when x equal to 1, y equal to 6. This is 3, this is 6. All right? Okay, good. The function, the curve, looks like this one at a very far away. Okay, approaches -2, passing through this point, passing through this point, passing through this point, passing through this point. Looks like this one very far away. Looks very far away like this. Looks this like very far away. Then we can join those pieces of data we got, and then we finally sketch the curve, right? This is the shape. This is the shape from infinity to -3, x, from infinity to -3. This is the point. This is the shape. This is the shape. And from -3 to -2, this is the shape. So this is the shape. This is the shape. And from -2 to 1, -1 is this is the point, right? Is this the shape? This is the shape. This is the shape. This is the shape. When this is the shape from -2 to 0, right? This is asymptote here, so the curve looks like this. Well, sorry, it's smooth. Should be smooth, and there's no sharp angle. Okay, and from 0 to infinity, that's the shape. This is the shape, and the asymptote is here, passing through this point, right? And the asymptote there. Wow. I hope you understand what I mean. This is far away asymptote, passing through this point. This is 1/6. Okay. And asymptote, passing through, this is the point, -1, 2. This is the minimum point. This is the minimum point, because the first derivative is 0. Okay, this is the point of inflection. Point of the second derivative is 0. This is a point inflection. Minimum point. All right, asymptote, 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 asymptote. Well, I think it's my camera. I didn't use. I cannot use the zoom, so I have to pan the camera to from. So I hope you understand what I mean. We are collecting informations for us to sketch the curve. The information given from derivatives, from asymptotes. Okay, the derivatives. These two pictures summarize the information of the shape of curves and maximum and so on. And second derivative 0 is a point inflection. Okay. There's no sharp angle, I'm sorry. The curve is smooth. Well, I have 6 or I have 8 videos of the series curve sketching. You can find from YouTube, and I hope you like it. Thank you for your watching.